So friends, now we will try to make sense of what is key rate duration. Now we were studying effective duration, right? Now in effective duration, what we understood is the bonds which have complexities in them, for them yield to maturity does not play an important role. What plays more of an important role is the market rates. It can be the spot rates, for example. And the change in those market rates basically determine what the effective duration of that bond can be. Now, what kind of change are we talking about? Now, when we say effective duration, what we are talking about is parallel shifts in the curve, market rate curves. So, let us try to understand what we are trying to say here. Let's say we have a bond which has a maturity of 5 years, right? It has a coupon of $10 and the par value is $100. Now, the maturity is 5 years, we have already said. So, therefore, the cash flows from time 1 to time 4 will be 10, 10, 10 and 10. And at time 5, the face value plus the last coupon will be received, which means the receipt will be 110. Now, at time t is equal to 1, 2, 3, 4 and 5, the spot rates or the market rates are 4%, 5%, 6%, 6.5% and 7% respectively. This is our assumption. Now this gives us the spot curve, right? Now when we are going to measure effective duration, what we are going to do is we are going to increase and decrease these rates by the same amount. Now you can see the charts here, friends. When there is no upshift, that is zero upshift or zero downshift, the spot rates and the spot rate curve after the upshift or the downshift overlap. So you can see here only one curve is there, right? In both upshift and downshift charts, there is only one rate, one curve. This is because both the blue curve and the orange curve are overlapped with each other. Now what happens during effective duration, as we said, we move each of the rates parallelly, that is by the same amount. So let us shift on the upside by 1% each of the spot rates. Let's see what happens. Now you see, friends, in this chart, there is a parallel shift. All the rates have moved up 1%. Similarly, let us do one more thing. Let us shift all the rates down 1%. Now you can see after the downshift, it has parallelly moved downwards. That is, all of the rates have moved equally downwards and there is a parallel shift. Now when we are trying to measure effective duration, this is what we do. We assume that all the rates are moving parallelly. Now in real world, this rarely happens. One of the rates move some percentage, the other rates may not at all move. So what we have to consider is impact of change of each of these rates individually. And in here comes the role of key rate duration. Key rate duration basically tries to understand what is the impact when every single rate changes individually, keeping the others constant. What we do is let us revert all the rates back to 0. Right? We revert all the rates back to 0. And what we are looking at is a specific rate change and the impact of it. So let's say we only change the second rate, 1% up or 1% down. What is the impact of this non-parallel shift at t is equal to 2? This measurement of impact is what we know as key rate duration measurement. Now friends, here we have just jotted down whatever assumptions we had made. Maturity of 5 years, coupon of 10 and face value of 100. The rates are 4, 5, 6, 6.5 and 7% at each of these times, right? Now for key rate duration, what we have to do is, we have to find out what is the impact of the change of each of these spot rates. For example, this one or this one or this one individually on the price of the bond, right? For that, what we do, for example, if we are to measure the impact of this single spot rate, that is at t is equal to 1, the spot rate is 4%, we want to understand the impact of the change of this rate. What we do is we keep all the other rates constant and change this up and down and try to understand the impact of it. Now, one thing that will be directly impacted by this spot rate is the present value of the cash flow, right? PVCF. Now, what we do is we can find out the PVCF of all of this, that is present value of all these cash flows, and we can calculate them. Okay. So, we go back to the Excel and find out the cash flows individually. So, here in the charts what we have done is time, the cash flows, the spot rates, amount of upshift and downshift we have considered, and due to these upshift, what is the impact on the spot rates? That is, after the upshift, what are the spot rates? After the downshift, what are the spot rates? We have already measured, right? Now, if we have to find out PVCF, that is the present value of the cash flow for the initial spot rates, that is PVCF 0, what we do is we divide the cash flow by the spot rate raised to the power of the time. So, cash flow divided by 1 plus spot rate by 100, because it's a percentage point, to the power the time. This comes to 9.62, and we can extend this for each of the calculations. Now, what we see is the present value of the cash flow number 1 is 9.62. If you check the Excel, it is 9.62, right? Now, this is the PVCF when the spot rate is at the initial rates. Now, let us tweak it a little bit. Let us raise the spot rate 4% and see what is the impact on the cash flow, and let us also shift it downwards and see what is the impact in the cash flow. We will again do it in the Excel. So, PVCF plus, that is after the upshift, what is the result? This is equal to, again, the cash flow divided by 1 plus the spot rate after the upshift, right? Plus upshift, rate after the upshift, to the power the time, right? This is the PV plus. Similarly, we can get the PVCF minus. So, this is for this individual cash flow, what is the present value coming, because when the rates go up, the present value comes down, and now if it's the rates come down, obviously the present value should go up. Let us see. 10 divided by 1 plus rate after the downshift by 100 to the power time. Okay. So, this is coming to 9.5238 and 9.7087, right? So, 9.5238 PVCF plus for the first cash flow, 9.5238, and PVCF minus is coming to 9.7087. Okay. Now, just let us stick to the first one only. Now, how do we calculate key rate duration for t is equal to 1? Because key rate duration is obviously for the individual timelines, not for the entire maturity period, right? For the individual time periods. So, key rate duration for t is equal to 1 is given by PVCF for 1 minus PVCF 1 plus, that is this one minus this one, right? PVCF minus for the cash flow at t is equal to 1 minus PVCF plus for the cash flow is equal to cash flow at t is equal to 1. This divided by 2 into quantum of the change of the spot rate, which is equal to 0.01 basically. This is 0.01 multiplied by PV0. What is PV0? PV0 is basically the sum of the PVCF for all these spot rates. So basically, when we go back to the Excel, see here we have measured all the cash flows. Now if we sum all of them up, the value that comes is the PV0, right? This is the PV0. Here in the formula also, you can see this is the PV0 which we are talking about. It is the sum of, if we write all the values here also and then write the sum here, whatever the sum value comes, you can see in the Excel, that is what is being mentioned as PV0. We have done this before also, right? Now we'll go back to the Excel and do the rest of the calculations. Now remember, we have tweaked the individual cash flow. So here, please note one thing, and on the numerator, it is PVCF of a certain period which is being taken. In effective duration or in modified duration, what we're doing is, we were doing PV plus minus PV plus, right? Here we are not doing this. Here we are taking a particular cash flow and the present value of that in the numerator to calculate the key rate duration for that particular period, right? So for t is equal to 1, we are finding out PVCF 1 when the rates raise, PVCF 1 when the rates go down, and then finding out their difference and putting it in the numerator. That is how we are finding out the individual key rate duration. So here, if we write key rate duration, this will be equal to PV minus PV plus divided by 2 into, you can say this shift is 1%, right? So it is 0.01 multiplied by PV0. Now we'll lock this PV0 because this is going to be the same value for each of the key rates. Okay. Now what we do is, previously what we did is we shifted all the rates parallelly. Now we shift back all these values. Right, we have shifted it back. Now these individual cash flows, when the other rates have not changed, what will they be? See, they are the same, right? This is 9.07, this is also 9.07, 9.07. That is how it will be, because we have not shifted this t is equal to 2 rates. We have not shifted them. Let us shift it for a while. Okay. Let us put this one back. Let us put this one back and shift this one. Now let us see what is the key rate duration coming to. So for t is equal to 2, the key rate duration is coming at 0.153. How do we measure it? Again, we have used the same formula. We have used the same formula only for the different timeline. So here what we have done is, we have found out key rate duration for t is equal to 2, and we have used the present value of cash flow 2. 2 minus 2 plus and divided by the same expression, 0.01 PV0. Okay. Now let's make the changes to each and every one of them. Okay. So we have shifted all of these rates 1% up and down, and the key rate durations individually have been found out. See. So this is, see, if I double click on this, it is basically PVCF 3 plus and PVCF 3 minus PVCF 3 plus divided by 2 into 0.01 multiplied by the PV0. This is all that is coming. Okay. If you similarly click on any of those values, this one again, it is only taking the cash flow of the t is equal to 4 period in the numerator and dividing it by the same expression 2 into 0.01 multiplied by the PV0. Okay, same goes here. These are the key rate durations, right? Now, how do we verify whether these calculations are correct or not? There is a way to do that, friends. The thumb rule is, basically you can say this is a postulate, sum of key rate durations should be equal to modified duration. Sum of key rate durations should be equal to modified durations. And modified durations is what, friends? Macaulay duration divided by yield to maturity, right? Divided by 1 plus yield to maturity. This is what modified duration is. So, just to verify that we have calculated the key rate durations correctly, let us check the modified duration and the Macaulay duration also. Now, to do that, we have to find the weights of the cash flows, right? Weights of the cash flows. How do we find that? We find that by dividing each of the cash flow by the total PV0, right? Again, we lock the PV0. See, the first weight is 0.08487. Similarly, all the weights we can find out. The next thing we do is we multiply these weights by the times, right? We multiply these weights by the time period at which they are coming. So, WCF multiplied by T. This is equal to weight into time. Okay, friends. So, this weight into time, this list of numbers, if you sum them up, what do you get, friends? What you get is basically Macaulay duration. So, this is sum of this is equal to Macaulay duration. This is the Macaulay duration. And let me write MacDur. And here, if you divide this by the expression 1 plus YTM, that is yield to maturity, you can easily find out what is the modified duration and verify whether the calculations are right or not, right? So, let us do that. Now, here we have the spot rates, but we do not have the yield to maturity. So, how do we find out the yield to maturity? It's very easy, friends. We have the present value, we have the future value, we have the PMT, we have the maturity. Just we have to find the yield. We can easily do that by the calculator. So, in calculator we enter present value is minus 113.28, N is 5, PMT is 10, future value is 100. The yield to maturity is coming at 6.78%. So, 0.0678%. This is the YTM. Therefore, modified duration is Macaulay duration divided by 1 plus the YTM. So, this is 3.94 coming to, right? Now, let us sum the key rate durations that we found out. Sum of these rates. Sum of the key rate durations that we have measured. Let's see whether it is coming nearby or not. Yes, it is coming to 3.39, which is, if you reduce the decimal number, it comes to 3.94, right? So, what we have done is correct. We have measured the key rate duration from the approximate formula calculation and used the postulate that the sum of the key rate duration should give you the modified duration, and then matched it. We have calculated the modified duration separately from the Macaulay duration and matched it with the sum of the key rate durations to find out that both are coming to be the same. So, this is all about key rate duration, friends. Again, to revise the definition, in effective duration, we look at parallel shifts in the curve, and in key rate durations what we look at is individual shifts in the curve. Individual shifts means these kind of shifts. Let's say the entire thing does not move, the entire thing remains 0, and we just move one of the rates, say the second rate, by 2%. Now what is the impact of that? We try to measure that. Okay, this is what key rate duration is.